Hello everyone, my name is Rohit Singhal and we were discussing about hydrocarbons. In the previous classes we have discussed about the alkanes and alkynes. We have talked about the isomerism of them, we have talked about structure to name of the hydrocarbons. Now in the upcoming classes, in today's classes, we will discuss about how to prepare, how to synthesize these alkanes, these hydrocarbons, what are the physical and chemical properties of these hydrocarbons, and how they are different in terms of reaction wise. So we will start with the alkanes. That alkanes. So first we will start with the preparation of it. Preparation. Though there are a lot of there are a lot of methods by which the alkanes can be synthesized. So we will start from first from the let us say alkenes, or we can say unsaturated hydrocarbons. How we can do is this, let us take an example of an unsaturated hydrocarbon, that is CH2 double bond CH2, that is an ethene. Now what we can form in there are two carbons. So the two carbon alkane we can form via an ethane, right. So CH2 double bond CH2, what we have to achieve, CH3 CH3, that we can form, right. So what we have to add to ethene to form ethane, and that is a 1H here and a 1H here. It means we need to add the hydrogen. So that is what we need to add, and do this reaction we need some catalyst, either palladium or nickel or platinum. This type of catalyst we use, these are the catalysts we use to do this reaction, and hydrogen we add, and this reaction is called, this type of reaction is called hydrogenation. So what is hydrogenation reaction? Hydrogenation reaction is basically the addition of hydrogen to any substrate to form the product. So in this reaction what we are doing, we are adding the hydrogen molecule to an unsaturated hydrocarbon to give the saturated hydrocarbon alkane. For this reaction we have to use some catalyst, that are the palladium, nickel or platinum. So also this is an example of reduction reaction. How this is a reduction reaction, you must have studied in the previous classes, that reduction means addition of hydrogen, or removal of oxygen. So what we are doing here, we are adding the hydrogen. So this is an example of reduction reaction. It is not only that we can form this from alkenes only, alkyne also we can have a similar thing, because that is also an unsaturated hydrocarbon. So from that also we can form, okay, this is 3 carbons, so we can form this CH3. From that also we can form the alkene. So it will be propyne to propane. Now the catalyst will be same, either palladium or platinum or nickel, but see how many hydrogens we have to add at this time. We need to add 2 hydrogens here and 2 hydrogens here. So we total have to add 2 hydrogen molecules. So 2 hydrogen molecules we have to add in the presence of palladium, platinum or nickel as the catalyst, and then we get the propane as the moiety. Okay. So this is how we can synthesize or prepare the alkanes from the unsaturated hydrocarbons, that is from the using the hydrogenation reaction as an example of a reduction reaction. So this is how we are going to prepare this. The another synthetic procedure we can use is from alkyl halides. From alkyl halides. Now, what are alkyl halides? Alkyl, you know, halides are what? This group 17th. Halides are 17th group elements. 17th group elements are known as halides. Example: fluorine, chlorine, bromine, iodine. Okay. So, what do you mean by alkyl halides? This is an alkene, okay, CH4. If I add one chloride here, this is an alkyl halide. Alkyl halide. Though we can add 2 also, CH2Cl2, this is also an alkyl halide, CHCl3, all these are alkyl halides. That means adding an alkane, adding group 17 elements to hydrocarbons. That is the meaning of alkyl halides. Okay. So, how we can synthesize the alkanes from this alkyl halides? Let us take an example of this alkyl halide only, CH3Cl. Now, what we will call as this CH4 is methane, okay, CH4 is methane. Now, what we had formed alkyl chloride. So, methane will form methyl, and what we have added a Cl group, that means a chloride. So, this will be named as methyl chloride. Now, what we have to form? One carbon we can form a methane here, right? We can form a methane. Now, what I have to do here is I have to add an hydrogen, remove a chloride. Okay. So, what in terms that means I have to add a hydrogen. Okay. So, what I will do? I will add a hydrogen molecule, but this time in the presence of zinc as a catalyst, and this H plus I will tell you what it means. So, what it will form as a byproduct, one H will go over the carbon and another H will go and take the Cl, and it will form HCl as a side product. Now, what is this zinc and H plus means? Okay, next class. So, I have used this zinc and H plus as the catalyst. Catalysts are basically the elements or the molecules added in the reaction to enhance the rate of the reaction. So, what is this zinc? Zinc is normal element catalyst, and what is H plus? H plus means protic acids, means the reaction is done, in presence of protic acid. Now, what do we mean by the protic acids? Protic acid means the acids that can give H plus. For example, HCl, it can be zinc HCl, it can be zinc H2SO4. That means we have used the combination zinc HCl or zinc H2SO4 or something else, whatever the protic acid. So, that is the meaning of the zinc H plus, it is written. So, what we have formed? CH3Cl, we have added a hydrogen molecule in the presence of zinc and protic acid to give us the methane. What happened to this hydrogen? This H, this one H went to the carbon, and this one H and Cl removed to form one HCl molecule, and that is how we get alkane as a product. Okay. So, this is how we can produce alkanes from the alkyl chlorides. So, two procedures we have seen till now, one is from the unsaturated hydrocarbons, it is alkenes or alkynes. The another we have seen is from the alkyl halides, alkyl, it can be bromide also, it can be iodide also, but it can be okay. Generally we do not use the fluoride because the fluorides are too much reactive. So, it can be CH3Br, it can be Cl, it can be I. We do not use fluorides. These are too reactive, so that is why we do not use it. It can explode something like that. So, we do not use fluorides to produce alkanes. This is the thing we have used either bromide, chloride or iodide. Okay. So, the two procedures we have seen till now. Okay, there is one another procedure, a very famous one, that is from carboxylic acids. Okay. Carboxylic acids, for example, CH3COH, CH3CH2COH, this is ethanoic acid, commonly called as acetic acid, or vinegar also. This is the formula of vinegar, the one we use in our households, in the noodles. This is propanoic acid. You must also not forget about the nomenclature I have taught to you. So, these are the things, ethanoic acid, propanoic acid. How we can synthesize from this is by the decarboxylation. Let us see. We will use sodium salt of acid to prepare or to synthesize alkanes. Now, how we will do it? Okay. So, let us take an example of ethanoic acid, CH3COOH. This is an acid. How we can form the salt of it? We will remove this hydrogen. For example, if we add it NaOH, what will we get? CH3COO minus Na plus. Okay. This is a salt, sodium salt of acid, and what will form? H2O will be formed as a side product. Okay. So, this is how we can produce this sodium salt. Now, how from this sodium salt of the carboxylic acids we can form the alkanes. So, what we will do? We will take this sodium salt, okay, and what we will add in the NaOH in this NaOH, and that too in presence of calcium oxide and heat. Okay. So, you must encounter with this symbol also, this means heating. This triangle sign means heating is done in any reaction. Whenever you see a triangle sign in a reaction, that means a heating is done. Okay. So, means the temperature is not specified at what temperature the heating is done, but this triangle means this is warmed or heated. The reaction conditions are not at the room temperature. Okay. So, what happens in this case? We will lose a carbon dioxide in this. We will lose a carbon dioxide in this and form a methane molecule, and this carbon monoxide will go on to react with Na and sodium and will form Na2CO3. Now, how this reaction is actually taking place? Let us discuss how this reaction is taking place. Now, what we are adding? We are adding NaOH and CO. Okay. So, what we are adding now? NaOH and calcium oxide. Okay. So, what happens? This calcium oxide is the presence of heating. So, what it does? It forms a Na2 So, what it will form? It form this moiety is removed and it forms a CH4, and this moiety, this 1 NaO, this CONa, this gives to form Na2, 1 carbon, 1 2 3, 3 oxygens, CO3. So, that is how the sodium carbonate is released and alkane are formed. So, this forms methane. We can use some higher salts also, we can use CH. If you have to form an ethane, okay, so this is an example of this reaction is called decarboxylation. Okay, decarboxylation. What do we mean by decarboxylation? Okay, so whenever such names are written in the in any books you encounter with, just try to break the word. Okay, decarboxylation. D wherever you seen is the will mean the removal. Okay, D means removal. For example, you see the dehydrogenation means the removal of hydrogen. Okay, so see that word. Okay, D means removal. What do we mean by D is removal? What do you can understand by carboxy? Carboxy means CO2. Okay, so removal of CO2 is called as known as removal of CO2 is known as decarboxylation. Okay, so this is an example of decarboxylation reaction. Okay, so one thing to keep in mind in this reaction, the alkane formed is of 1 carbon less than that of sodium salt taken. That means loss of 1 carbon from starting material. Okay, 1 carbon is lost in the synthesis, and that 1 carbon is lost in the form of Na2CO3. Here it has been lost. Okay, so that 1 carbon lost is means the alkane, whatever the alkane is formed, it is of 1 carbon less than the sodium salt of acid we have taken. Okay, so this sodium carbonate and this carbon is lost, that means it is not lost from the reaction. Obviously, we have to maintain the reactant weight and the product weight. So, the carbon is not lost in the reaction, it has gone in the formation in the form of a side product, that is sodium carbonate. So, these three till now I have discussed about the preparation of the alkanes or saturated hydrocarbons. In the next class I will discuss about the properties and maybe a few 1 or 2 more synthetic procedures of alkanes. Okay. So, in this class that is it for now. Thank you so much.